So today we're going to do the first day, and we're probably going to spend about 3 days on this lesson. It's over the unit circle, and it is a 13-4. And there's actually a lot of things you already know about the unit circle, but I want you to look at this little triangle that's been drawn here. Every angle measure that goes all the way around the unit circle can have a right triangle drawn from the origin to the circle will be the hypotenuse. The vertical leg of that right triangle will be the distance for the y value of this ordered pair that's right here on the circle itself. And then the distance from the origin to here is the other leg of the right triangle, and that will represent the x value. So why don't you go ahead and put a little x here and a little y there. And so, as we've talked about in the past, if theta is our angle of reference, then side opposite would be where the y is, side adjacent would be where the x is, and then the hypotenuse would be where the 1 is. So if we were doing sine, and actually let's prep these with their fraction bars. So we like to talk to ourselves. I've taught you to talk to yourselves. Some old hippie caught another hippie tripping on acid. So we're just going to write out our ratios for sine, cosine, and tangent according to this x, y, and the 1. So according to those, for sine, side opposite is y, and your hypotenuse is 1. So that means that the sine of theta, whatever angle that might be, is the y value of that ordered pair. So whatever the y value is of that ordered pair, that represents the sine of this theta. So right there, that's going to be your sine. And then for cosine, our side adjacent in this case is x, and our hypotenuse is 1. So that means that the x value is going to represent our cosine. So in this ordered pair, the x value is cosine, the y value is sine. So the coordinates of P can be written in a different way. They can be written as cosine theta, comma, sine theta instead of xy. Our x is the cosine, and our y is the sine. And then tangent, according to this triangle, is the side opposite over the adjacent. So it will be considered y over x. And what that means is that in this circle, right here, we can also find tangent by taking this y value and putting it over x. In other words, y, which is sine, will be put over cosine. So I'm going to rewrite tangent as sine of theta over cosine of theta. It's just another way of looking at the tangent. And so ponder that for a moment. I know all of this is new and it's going to be overwhelming, which is why we're spending 3 days on it. All right, so then let's look at our special angles. We spent a lot of time again looking at these special angles and determining what their sines, cosines, and tangents are. We really haven't looked at sine, cosine, or tangent for these ones here. These are typically 0 and 360, 90, 180, 270. They're all where the axis ends lie. That's north, south, east, and west. So these are quadrantal angles. And I'm going to show you how, as we go through this lesson, how we get the values here. And I'm going to be more specific as we get into the unit circle itself and how I derive it. So a lot of people will just memorize everything that you see here they'll just memorize everything here about the unit circle and just spit it back out. So I am going to write down these items, and you can memorize them if you want to, but I'm going to teach you how to derive the unit circle in the next couple slides. So look, magic. So go ahead and pause the video and write this down, and then I'm going to do a real quick discussion as to how you could memorize if you want to, but you know how I feel about memorization. I'm not really big on it. Okay, so of course I've taught you how to convert these by using pi over 180 degrees. So multiply each one of these by pi over 180 degrees and reduce, and you get your radians. So you can go ahead and memorize these for your sine and your cosine. I'm going to teach you how to use your special right triangles to get those. And then for the tangent, all I did was take sine and divide it by cosine, your sine divided by your cosine, to get these purple values here for tangent. And of course your ordered pair is just cosine and sine. So your cosine and then your sine. So 1, 0, rad 3 over 2, 1/2, and so forth. Okay, so now we're going to flip your page and just look at the top half for today, and then we'll go into the unit circle. In addition, I'm going to also post a video that shows a hand trick for your left hand for you to be able to memorize each of these values, so your degrees, with each of these values here. So if you're wanting to really memorize, the hand trick can really actually help you with that, and it's pretty quick. All right, so let's look at the rest of this. All right, so on the back of this page, we are going to explore signs of all the trig functions, sine, cosine, and tangent, in the coordinate grid. So the first thing I need you to do is to remember which quadrants are which. In other words, how are they numbered? So this is quadrant 1, Roman numeral 1, and then going counterclockwise the direction of our positive angles, that's quadrant 2, and this is quadrant 3, and this is quadrant 4. So if you memorize the phrase, all students, and you can see it's down here, right? All students, and write it up here too, take calculus. You can never go wrong with figuring out what sign, because sine, cosine, and tangent can be positive or negative. And so remember, this is your positive quadrant because it's surrounded by two positive axes. This is your positive negative quadrant because it's surrounded by a positive and a negative axis. This quadrant 3 is your negative quadrant because it's surrounded by two negative axes. And this is a positive negative quadrant because it's surrounded by a positive and negative axes. All of these, when you do side opposite over hypotenuse, or adjacent over hypotenuse, or opposite over adjacent, those are all your ratios for sine, cosine, and tangent. All of those signs can create either a positive or a negative value. So what all means is that all trig functions, sine, cosine, tangent, and their inverses, will all be positive. All of this refers to just positive values. In quadrant 2, the only trig function that is positive is sine and its reciprocal function, which is cosecant. And then in quadrant 3, take, oh, and I forgot to mention all means all. S means sine. And so in quadrant 3, take must mean tangent. So only tangent and its reciprocal function, cotangent, are positive in quadrant 3. And then in quadrant 4, C for calculus is cosine. So cosine and its reciprocal function, which is secant, are the only ones that are positive. So in quadrant 1, that means that all functions are positive. In quadrant 2, students means sine. is the only trig function positive. And I'm not going to write the reciprocal functions, but that of course would be cosecant. And then in quadrant 3, take would be tangent is the only one that's positive, and its inverse function, which is cotangent. And then quadrant 4, C for cosine, that's actually cosine, and its reciprocal function, which is secant. So then you're going to be asked questions all the time about, if the tangent is positive, what quadrant could it lay in? If secant is negative, because less than 0 means negative, greater than 0 means positive, what quadrant could it be in? So questions 1, 2, and 3 are actually fairly simple questions. So we'll start with those. Question 4 gets into a more complicated process that you'll use often in pre-calculus. So first question here, if tangent of theta is greater than 0, meaning that it is positive. So we're looking for where tangent is positive. Which quadrant could the terminal side of theta lie? And so in other words, if this is your initial side, and we go all the way either to quadrant 2, 3, or 4, where could my terminal side of my theta end? So for tangent to be positive, the only places where tangent is positive is all, because they're all positive here, or here in quadrant 3, where it says take for tangent. So the only quadrants where tangent is positive is quadrants 1 and quadrants 3. That's all it's asking. So I'm going to put here Q1 and Q3. So then question 2 says if secant of theta is less than 0. So less than 0 means we want to know where it's negative, so I'll talk about how you determine that. But secant means the same thing as its inverse function. So remember I said that sine and its inverse function were positive in quadrant 2. Tangent and its, I'm sorry, I said inverse, I meant reciprocal function. Tangent and its reciprocal function in quadrant 3, cosine and its reciprocal function in quadrant 4. So secant of theta, remember, is equal to 1 over the cosine of theta. So cosine is where I want to focus my energies on, and so cosine is negative, all right? So it's easier for me to determine where is cosine positive. So cosine is positive in quadrants 1 and also here in quadrant 4 because of calculus. So if cosine is positive in these two quadrants, it must be negative in these two quadrants. So the answer to this would be Q2 and Q3. All right, so for question 3, if sine of theta is greater than 0, meaning positive, which quadrants could the terminal side of theta lie? So I'm going to let you think about that for a minute. All right, so for sine to be positive, sine is positive in quadrant 1 because all are positive in quadrant 1. And sine is positive in quadrant 2 because that's where S for students refers to. So if you guessed quadrant 1 and 2, you are correct. All right, so then question 4 is a little bit more involved, so I'm going to scoot my notes over here a little bit because this time they're asking you if cosine is negative and cotangent would be the same sine-wise as tangent is positive. So we want to know what quadrant is cosine, both cosine negative and tangent positive. So let's draw over here to the right a little coordinate grid. And then I'm going to put in here that this is quadrant 1. Actually, I'm not going to put that. So we're going to put all students take calculus. So that's my abbreviation. So let's start with where cosine is negative. So remember, if we're looking at the negative, I like to look at where it's positive first, and then the other two quadrants must be negative. So cosine is positive in the first quadrant and the fourth quadrant. All calculus, all meaning cosine, right? So if cosine is positive here, cosine is negative in quadrants 2 and 3. So I'm going to put a little star here in quadrant 2 and a little star here in quadrant 3. Then let's look at cotangent, which is the same as tangent. We want to know where is cotangent positive. So tangent is positive in quadrant 1 because all are, and over here in quadrant 3 because that's where tangent's positive, and so is cotangent. So I'm going to put a star here and a second star here. Because quadrant 3 has both stars overlapping in this quadrant, the answer to our question, where is cosine negative and cotangent positive, has to be in quadrant 3. That is the only time where those two overlap. So Q3 is your only answer to this one. Now we're going to go into the unit circle, and I'm going to teach you how to derive the unit circle rather than memorize it. And hopefully that'll be easier for most of you. All right, so here you see our unit circle. A couple things you need to understand. The unit circle, of course, as we've talked about, starts with 0, goes all the way around and ends with 360. Again, you could memorize all of these pieces around here. These are all the coordinates. This is the ordered pair for cosine and sine of 30, cosine and sine of 45, cosine and sine of 60, and so forth. All right, but remember that we assume that there is a radius of 1, calling it the unit circle. So I'm going to start off with my special right triangles over here to the right. So my smallest special angle here is 30 degrees. So I'm going to draw a right triangle, and I'm going to put 30 degrees in here, which means that 60 degrees would be up here. And if you recall on our 30 degree, 30, 60, 90 triangle, it has a special pattern. Across from 30 is 1, across from 60 is radical 3, and the hypotenuse is 2. So according to our angle of reference, and maybe, I'll do it below it. According to our angle of reference, this is the side opposite, this is the side adjacent, and this is the hypotenuse. So the sine of 30 is equal to, that's some old hippie, right? So the sine of 30 is equal to opposite for old, so that's 1, and then hippie for 2. So the sine of 30 degrees is 1/2. Then the cosine of 30 degrees is caught another hippie, so adjacent, radical 3, over hypotenuse 2. All right, so then let's do, our next angle is 45, so then let's do our 45, 45. And our pattern for this is across from each of the 45 degree angles is 1 and 1, and then the hypotenuse is radical 2. And so let's let this 45 be our angle of reference. So according to that 45, this is the side opposite, this is the adjacent, and this is the hypotenuse. That actually says hypotenuse. And then the sine of 45 degrees is equal to opposite, which is 1, over hypotenuse, which is radical 2, and if we rationalize that, which we've done this a lot already, it should be rad 2 over 2. So you're just multiplying top and bottom by rad 2 over rad 2, And when you get that, it simplifies to rad 2 over 2. And then cosine of 45 degrees is identical. 1 over rad 2, so it also is rad 2 over 2. All right, so I'm going to try to squeeze in. Maybe I'll squeeze in my 60-degree special right triangle up here. That's a right angle. This is my 60 and then my 30. And then across from my 30 degree is 1. Across from my 60 is radical 3. And my hypotenuse is 2. So notice on the 60-degree triangle where 60 degrees is here versus 30 degrees here, my 1 is down here versus over here. So they do switch, which is important to note. So if this is my angle of reference, this is my side opposite, this is adjacent, and this is the hypotenuse. And then that means that the sine of 60 is equal to opposite, which is radical 3, over the hypotenuse, which is 2. And then the cosine of 60 is equal to adjacent, which is 1, over the hypotenuse, which is 2. And remember, we talked about the fact that the sine and cosine of 60 and the sine and cosine of 30 flip-flop. All right, so based upon my right triangle information, that's what we're going to write for sine and cosine. So I know that, remember, in my unit circle, my ordered pair goes, where am I going to squeeze this? My ordered pairs go cosine of theta, comma sine of theta, right? So here we go. For 30 degrees, cosine is radical 2 or radical 3 over 2. So radical 3 over 2. And then my sine, which is my y value right here, it is going to be 1/2. So sine is 1/2. And then remember, both the sine and cosine of 45 degrees is the same. So for 45 degrees, it's going to be radical 2 over 2, radical 2 over 2. And then for 60 degrees, our cosine goes here. So that means 1/2 comes first. And as you can see, it's flip-flopping from the 30 degrees. And then the sine of 60 is radical 3 over 2. So those are really the only ones that you need to know. And then we are going to reflect all of these over here, and then reflect these down here, and reflect these over here. But before we do that, I want to talk about these 4 axis points here. So they are our north, south, east, and west. Let's see what happens if I try to move this up. Oh, perfect. All right, good. I want to move that up just a little bit. Okay, so remember, if from here to here is a distance of 1, this coordinate point right here is going to be to the right 1, but up nothing. So this is right 1, up nothing. So what that means is that if this is the x value, then that is the cosine of 0 degrees and also 360. So the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. And you saw that in that spreadsheet in your notes before this. And so that's where these come from. Same thing's going to happen up here at 90 degrees. So at 90 degrees, if this is the origin, that means I did not go right or left at all. So our x value here is going to be 0, but we went up 1 to get to this ordered pair here. So we went right or left, nothing, but up 1. So then for 180 degrees, we went left 1, which is a -1, and up nowhere. So this ordered pair is going to be -1, 0. And then at 270 degrees down here, we didn't go right or left. So our x value is 0 and down 1. So that's going to leave us with 0, -1. So now we have our north, south, east, west access points, and then all we have to do from this point is reflect, remembering that our x values are negative in this quadrant and our y values are positive. So this is going to go directly over here exactly as you see it. So I'm going to transpose those. So and if you think about it, I'm transposing this, reflecting this all the way across here at 150 degrees. Remember what my reference angle is? The difference between 150 and 180 is 30 degrees. Jojo is scratching herself, if you can hear that in the video. And so the sine and cosine are the same for the reference angle as it is for 150 degrees. Remember, from here to here is 150 degrees, and then this reference angle, they are coterminal. So for 150 degrees, I have negative radical 3 over 2, but a positive 1/2 because y values in quadrant 2 are positive. Then I'm going to translate this over here. So they both are rad 2 over 2, but the x value is negative and the y value is positive. And then that leaves us moving the 60 degrees over here, and notice that 60 degrees is the reference angle to 120 because it's 60 degrees from 120 to 180. So we're going to move the 1/2 and the rad 2 over, or rad 3, that's actually a 3 over here, but the x value is negative, so -1/2, but a positive radical 3 over 2. Then we're going to translate each of these down here. But all values x and y are negative in the third quadrant. So 210 degrees is the same as negative radical 3 over 2 and -1/2. And then 225 is negative rad 2 over 2 and negative rad 2 over 2. Try to squeeze that in there. And then 240 degrees is -1/2 and negative radical 3 over 2. So again, 150 reflected over to 210, 135 reflected over 225, they're equal distance from the x-axis, and 120 reflected over to 240, all equal distances. All right, all that's left is quadrant 4, so we are going to reflect quadrant 3 over to quadrant 4. X values are positive, y values are negative. So 240 reflects over to 300, so I have 1/2 and a negative radical 3 over 2, and then 225 over to 315 is positive radical 2 over 2 and negative radical 2 over 2, and then 210 reflects over to 330, so positive radical 3 over 2 and -1/2. Now all that's left is to do our radian counts. So we have to count and convert these degrees by radians. Rather than converting them, I guess you could, but you need to learn to count by fractions. So we are going to start with, and I count these in groups. So I'm going to start with my quarters. So I'm going to put those in red. So this is 0. And then my first quarter is 45 degrees. So 45 degrees is 1/4 of the distance, because remember, from here to here is a half. 45 degrees is halfway to 90. So that's half of a half, which is a fourth. So this is 1/4. This will be 2/4. 2/4 is 1/2. 2/4 reduces to 1/2. So that's 1/2 pi, or pi over 2. And then 3/4 would be here. That's halfway. So 135 is 3 pi over 4. And then 4/4 would be here. Well, 4/4 reduces to pi. And then 5/4 would be here at 225. So that does not reduce. 5 pi over 4. And then 6 pi over 4 reduces to 3 pi over 2. And then 7 pi over 4 does not reduce. And then finally 8 pi over 4 reduces to 2 pi. So that's 2 pi. So that's our quarters. So again, 0, then 1/4, 2/4 reduces to 1/2, 3/4, 4/4 reduces to 1, 5/4, 6/4 reduces to 3/2, 7/4, and then 8/4 reduces to 2 pi. So that's our quarters. You got half of them. It should be pretty simple. Then you need to start counting by thirds. So when you count by thirds, this is 0, and 1/3 of this, so here's pi, so 1/3 from this distance to here is 60. If you take 180 degrees and divide it by 3, you get 60. So from here to here is 1/3. Then add 60 more, that would be 120, that's a second third. And then add 60 degrees, that's a third third. So you keep adding 60 degrees to count by thirds. So I'm going to change colors. I think I'll use blue on this one. So again, this is 0. 60 will be my first third. So this is pi over 3. And then 2/3 would be here at 120. So 2 pi over 3. 3/3 would be at pi. So we already have pi written there. 4/3, we're going to add 60 to the 180. So 4/3 gets us here to 240. And 4/3 it does not reduce. So we're going to put 4/3, 4 pi over 3. And then 5/3 add 60, you're going to get to 300. So 5 pi over 3. And then finally 6/3, which gets us back to 2 pi. Finally, we're going to count our 30 degrees, which we have converted 30 degrees to pi over 6. If you multiply 30 degrees by pi over 180, 30 goes into 186 times. So it's pi over 6. So I think I will use, I guess I'll use this ugly orange, but this is pi over 6. So we're going to count by 6, which is every 30 degrees. And we don't have that many to fill in. So this is all the blanks are the rest that's left. So this is 1/6, 2/6, 3/6, I'm counting by 30s, 4/6, this is 5/6, which we need to fill in. So 5 pi over 6. Then from here, 6/6, 7/6, so we need to fill that in. 7 pi over 6. So from 7/6, this is 8/6, 9/6, 10/6, 11/6. That's the last one that needs to be filled in. 11 pi over 6, because that brings us to 12/6, which is 2 pi. And that's it. You have done everything you need to label that unit circle. And I only label the unit circle for what I need when I need it, but and you're going to be expected to be able to do that. So whether you memorize the values or you derive it, there you go. And your job between now and the next 3 days is to practice, practice, practice. All right, so let's summarize the signs and the quadrants. So again, in quadrant 1, 2, 3, and 4, we're going to determine what's positive and what's negative. So I'm going to put above here our little mantra that I taught you, which is all, that's for quadrant 1, students take calculus. I'll totally miss that one, calculus. All right, so remember, all means all, S means sine, T means tangent, and C means calculus for the ones that are positive. So if all are positive in quadrant 1, then all of these are positive. None are negative in quadrant 1. In quadrant 2, only sine is positive, so the rest are negative. In quadrant 3, only tangent is positive, so the rest are negative. And in quadrant 4, only cosine is positive, and so the rest are negative. So you will be expected to determine that as well. And then our trig values. Remember that in that ordered pair, sine is your y value, cosine is the x value in that ordered pair, and tangent is y over x, which is exactly equal to sine of theta over the cosine of theta. And I think that's enough torture for today. All right, work on the assignment I have posted, and good luck.